Hi, this is Mr. Manley. In this video, we are going to look at a function operation called composition. Maybe you've looked at addition, subtraction, multiplication, division of functions. Here we are doing the composition of functions. The notation for composition here, and I'm going to expand that a little bit, a Q, and then there's this open dot R. So look at, if I just compare that to multiplication, Q, and then a closed dot R. So that's what we have to look for. Sometimes that open dot's a little bit difficult to see. You might have to really look closely, or just look at what the problem is asking. It may be that it's hard to see, and maybe you do multiplication by mistake initially. But there is what we're looking for: open dot, closed dot. So the open dot is composition, and the way that this would be read, if I just take this bottom one here, is the composition Q and R of 4. The composition Q and R and 4. I could say Q composite R of 4. So there's where this word composition can come into the way that I'm reading it. But the most useful way of reading it is to read it like this: Q of R of 4. So there we don't use the word composition, but this really gets more to the point about what this operation is. What is this composition operation? It is Q of R of 4. So that should help me rewrite this in a useful way. So if I take this out here and say Q of R of 4. So it might be like, if I think about it like this: Q of R of 4, and I put parentheses around the R of 4. So I'm going Q of R of 4. Now, once I rewrite it like this should be really simple. I hope that you've seen enough of functions to say, like, well, what if I just ignored this Q? Would you know what to do with R of 4? I hope so. Hope you've done this many tens of times. R of 4, so that means I'm going to plug in a 4 for X. And then plugging in a 4 for X, I would get -4 plus 3 is -1. So now I know that R of 4 is -1, and I can do that substitution. So I've got Q of -1. Now again, I'm looking at something that I've done tens of times before. Me personally, I've done it hundreds of times, if not 1,000 times. Now for you, hopefully you're familiar enough with this that you say Q of -1 means plug in a -1 for this X. So I plug in a -1, and I have -2 times -1 plus 4, and then that's -2 times -1 is 2 plus 4 is 6. So one thought that I want to get out of your head at this point is I want you to really be tuned into function notation. This is not multiplication. This is not Q times -1. This is Q of -1. Q of -1. That's a function notation, which means that Q is some algebraic expression, in this case -2x plus 4, and -1 is the value that I want to plug in for X. So hopefully we're heading that off, because I do see students do that sometimes, and they want to think of it as multiplication. All right, let's move on. So here I've got a function composition. I'm being asked for a function composition, and it's not numeric. So the other one was numeric. This one is algebraic. F composition g of x, f of g of x. So let's just do that. Let's do that rewriting the way we did before. F of g of x, and this is really the best way to conceptualize composition. I think it's pretty, and then we can just go back to our basic understanding of function and how functions work. So f of g of x, now g of x is sitting right here, right? That says g of x is x minus 3. So I can plug in an x minus 3 for g of x. That's just a substitution. Very common in mathematics, looking for ways to substitute. Now I've got f of x minus 3. So this x minus 3, all of this is going to go in for the x over here. That is the function f. All right, so I'll write that out in detail here. That's going to be, I'll just go right below it. 5 times x minus 3 plus 25. Let's see if we can simplify that. 5x minus 15 plus 25. And then I've got, looks like 5x plus 10. So let's see, look at that. And that looks good. And that is the answer to this first part. Here, square root of 5x plus 10. And that is the algebraic composition of two functions. No numeric substitution or analysis happening here. The second part of the question, what's the domain here? I have a separate video for that. So maybe I can just look at one more composition. Say I had f of x equal to x minus 2 over x minus 3, and then g of x is equal to 2x plus 1, and I'm asked for the composition of f and g of x. So that is going to get rewritten, f of g of x. I'm going to substitute g for g of x, which is equal to 2x plus 1. So I can substitute 2x plus 1. And then I'm going to substitute 2x plus 1 for the x's, both x's up here. I'm going to substitute it for both of them. And then that will get me 2x plus 1 minus 2. So that there's the substitution for the first x, or the x in the numerator. Here's the substitution for the x in the denominator. And then we can simplify that. 2x plus 1 minus 2, that's 2x minus 1. And 2x plus 1 minus 3, that's 2x minus 3. Okay, so there's, we started off with a numeric evaluation, or a numeric composition here. And then we finished off with a algebraic composition here and here.